Lesson 8.2b, independent and dependent events. So we are continuing our discussion on probabilities. Independent and dependent events, I think they're better described with examples, but I'm going to go ahead and read. The probability of two independent events can be found by multiplying the probability of the first event by the probability of the second event. So if they are two independent things, two random things that don't really go together, what's the probability of them both happening? They are not related. One does not depend upon the other to happen. That's independent events. So to kind of give you an idea or an example, look at example 1. It says two number cubes, one red and one blue, are rolled. They're two separate number cubes. They're two separate. One doesn't control the other one. You're just rolling two of them. What's the probability the outcome of the red cube is even and the outcome of the blue cube is 5? So they're two separate things. You throw both of them. So the probability that the red cube is even, we've already done that when we looked at simple probability. To get an even on a number cube is 1/2. The probability of getting a specific number on a cube, getting a 5, 1/6, because there's 1 5 out of 6 sides. So to get the probability that both things would happen, you'd take 1/2 times 1/6. You multiply them together, 1/12. So the probability of two independent things happening, you multiply them together. Okay, now that is completely different than dependent. One thing does depend upon the other. And hopefully you'll see that in a minute. So, dependent, if two events A and B are dependent, the probability of both events occurring is the product of the probability of the first event, A, times the probability of B after A happens. Okay, so what does that mean? So let's say you're drawing marbles out of a bag at random, and if you take one marble out of the bag and don't put it back in, it's called without replacement. Doesn't that change how many marbles are in the bag? So the probability would be different for that second draw or third draw because the whole scheme of the bag would change. And that's what this is talking about. Dependent events. So the example is there are 6 black socks, 4 white socks in a drawer. If one sock is taken out without looking and the second is taken out, what's the probability you'll draw out 2 black socks? So the first sock is being black would be 6 out of 10 because there's 6 black socks out of 10 socks in the drawer. 6 out of 10 or 3/5. Now, after you take one sock out of the drawer, how many socks are in there? 9. Specifically, if you've taken a black sock out of there, how many black socks are there? 5. So the second time for drawing a black sock, it's a different probability. It would be 5/9. 5/9, 3/5 the first time and 5/9 the second time. So basically, the second draw is different than the first because the bag, or in this case, the drawer has changed. So let's look at our examples. For exercises 1 through 6. For the first event, a card is drawn from a deck of 10 cards numbered 1 through 10. The second event, a number cube is rolled. Okay, so we've got a deck of cards 1 through 10. We've got a number cube 1 through 6. The very first problem says, oops, that is not what I wanted to happen. Let's go back. The very first problem, it says, what is the probability of drawing a 10, and rolling a 3. So out of that deck of cards, what is the probability of getting the 10? What is it? 1/10. So 1/10. I'm going to put it all over here because I cannot fit this in here any better. Well, maybe I can. Let me make it a little bit bigger. Okay, I can. So first of all, for the 10, the probability of the 10 is 1/10. Okay, now what's the probability of rolling a 3? Caden? 1/6. So 1/10 times 1/6, the probability of both of them occurring,
260.
multiply straight across, it'd be
1/60.
1/60.
Yeah. That equals 110. Wait, no.
1/60. Caden?
How many are 1/6?
On a number cube, there's 6 sides, and the probability of rolling a 3, so 1 3 out of 6 sides, 1/6. Okay? All right. Number 3, 2 prime numbers. 2 prime numbers. So we need to know what prime numbers are. Okay? Prime numbers are numbers that only have factors of 1 in itself, right?
Yes.
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 Now, here's the thing. 0 and 1 are not prime nor composite. So they are not either. So what is my smallest prime number?
7. Wait, no,
2. Is 3 prime?
Yes.
Is 4 prime?
No.
5?
Yes.
6?
No.
What about 7?
Yes.
What about 8?
No.
What about 9?
No.
What about 10?
No.
Okay, so here's the prime numbers that we'll have to be concerned with. So first of all, we're talking about prime numbers out of the deck of cards, 1 through 10. How many of those cards in that deck are prime?
4 out of 10.
4 out of 10. So this would be 4 out of 10. Now, what about the, and then that reduces to what? 2/5. So let's make that 2/5.
Does it matter if we reduce it or not?
You're going to end up reducing at the end anyway, so you might want to do it early on so the numbers aren't so big. So 2/5. And then on a number cube, 1 through 6, how many of those are prime?
3, 6.
3/6.
Oh, I drew my line in the wrong spot.
1, 2, 3.
2, 3, 5, right?
3,
So 3/6, which is 1/2. 1/2. Cross out. Those become ones. What's the probability of
1/5.
1/5?
This
Okay.
is pretty easy.
Okay, number 5. What's the probability of having 2 numbers less than 4? Less than 4. So with that deck of cards, how many numbers are less than 4?
3
3. So it's 3/10.
and 3, 6.
And then less than 4 on the number cube.
3, 6.
Less than 4 would be 1, 2, 3. 3 out of 6, which is
1/2.
1/2. So 3/10 times 1/2, you can barely read that. 3/10 times 1/2 would be what? 3/20. 3/20.
Okay, this is really easy.
All right. Let's do the dependent events now. There are 4 red, 6 green, 5 yellow pencils in a jar. Once a pencil is selected, it is not replaced. That's what I was talking about. One depends on the other. Once you pull a pencil out, the number of pencils in the jar are all different. So we want the probability of pulling out a red pencil, then a yellow. So first of all, the red would be what? How many pencils are in the
4.
jar?
15.
15. So pulling out a red would be what?
4 out of 15.
4 over 15. Now we want yellow, but keep in mind we've already pulled a red pencil out. You've already got to pretend that you've done the first thing in
Should
order
be
for it to
14.
work. So there's 14 now in the jar. How many are yellow?
5.
So 5 over 14, right?
Yeah.
Okay. Do I have anything that cancels out here? Yep, 5 and 15 become a 1 and a 3. Anything else? 14 and 4 can be divided by what? So that would be a 2 and a 7. And then if I multiply straight across, what am I getting?
2 over 21.
2 over 21. Good. Okay, what about a green then a yellow? A green then a yellow. So we're going to put all the pencils back in the jar now. Start all over. So I want a green. The probability of getting green.
6, 15.
6 out of 15. Does that simplify?
Yes.
Yeah.
2. No.
Divide them both by 3.
Oh, yeah. It's going to be 2/5.
So this is really 2/5. Okay, now we've taken a green pencil out. What's the probability I'm going to get a yellow? 5/14. Does anything cancel? The 14 and the 2 become a 1 and a 7, and the 5s both become 1. So the probability of a green than a yellow, 1/7.
How would it be? This is a lot easier though.
Because you take out a
We took not a marble. We took a pencil out. There's only 14 in there now. There was 15 to begin with, and we took a green one out.
That seems a lot easier.
One that I definitely want to do is number 8. So we're going to do the probability of 2 green pencils in a row.
What?
2 green pencils in a row. So there's 6 green pencils to begin with out of 15 pencils altogether, right? So the first green pencil 1, is 6 out of 15. Everybody good with that? And what does that reduce to?
What was it? 2/5?
2/5. Because you divide them both by 3. Now, green pencil 2. Now, here's the thing. These green pencils, if I look over here, there's really now 5 in there, isn't there?
Oh, that's what I was going to say. So would it be
Yeah,
5 over
5
15?
5/14. 5/14.
And then you times that and get your
Cancel out. The 5s both become 1s, and the 2 and the 14 become 1 and 7. So again, 1/7.
Okay, this
Yes.
that's easy.
Why did we go in reverse? We did 6, 7, 15 equals 2 over 5.
Well, 6 over 15 reduces to 2/5. I reduced that.
Oh,
So that's still the first green pencil. I reduced it before I started multiplying.
I thought that was the answer.
No. I reduced it, and it was 2/5 and then 5/14. Good question, because if somebody thought that was the answer, yeah, okay. I reduced that first pencil to 2/5. All right, any other questions?